Hi, today we are going to see about RLV LEX case study video. ISRO successfully conducted the Reusable Launch Vehicle Autonomous Landing Mission, that is RLV LEX. The test was conducted at the Aeronautical Test Range, Chitradurga, Karnataka, in the early hours on April 2023. The RLV took off at 7:10 a.m. at Indian Standard Time by a Chinook helicopter of the Indian Air Force as an underslung load and flew to a height of 4.5 kilometers above MSL. Once the predetermined pillbox parameters were attained based on the RLV's mission management computer command, the RLV was released in mid-air at a downrange of 4.6 km. Release conditions include 10 parameters covering position, velocity, altitude and body rates, etc. The release of RLV was autonomous. RLV then performed approach and landing maneuvers using the integrated navigation, guidance and control system and completed an autonomous landing on the ATR airstrip at 7:40 a.m. Indian Standard Time. With that, ISRO successfully achieved the autonomous landing of a space vehicle. The autonomous landing was carried out under the exact conditions of a space re-entry vehicle's landing, high-speed, unmanned, precise landing from the same return path as if the vehicle arrives from space. Landing parameters such as ground relative velocity, the sink rate of landing gears, and precise body rates, as might be experienced by an orbital re-entry space vehicle in its return path, were achieved. The RLV legs demanded several state-of-the-art technologies including accurate navigation hardware and software, pseudolight system, radar altimeter, navic receiver, indigenous landing gear, compens and brake parachute system. In a first in the world, a winged body has been carried to an altitude of 4.5 km by a helicopter and released for carrying out an autonomous landing on a runway. RLV is essentially a space plane with a low lift to drag ratio requiring an approach at high glide angles that necessitated a landing at high velocities of 350 km per hour. LEX utilized several indigenous systems. Localized navigation system based on pseudolight systems, instrumentations and sensor systems were developed by ISRO. Digital elevation model of the landing site with a K-band radar altimeter provided accurate altitude information. Extensive wind tunnel tests and CFD simulations enabled aerodynamic characterization of RLV prior to the flight. Adaptation of contemporary technologies developed for RLV LEX turns other operational launches vehicle of ISRO most cost effective. ISRO had demonstrated the re-entry of its winged vehicle RLV-TD in the HEX mission in May 2016. The re-entry of a hypersonic suborbital vehicle marked a major accomplishment in developing reusable launch vehicles. In hypersonic suborbital vehicle, that is HEX, the vehicle landed on a hypothetical runway over the Bay of Bengal. Precise landing on a runway was an aspect not included in the HEX mission. The LEX mission achieved the final approach phase that coincided with the re-entry return flight path, exhibiting an autonomous high-speed landing with a speed of 350 km per hour. The LEX began with an integrated navigation test in 2019 and followed multiple engineering model trials and captive phase tests in subsequent years. The uniqueness of LEX. The assessment questions are: what is RLV LEX? What is the use of RLV? And which is the first reusable rocket in ISRO? Thanks to ISRO for providing the informations regarding RLV LEX. Thank you.